Well, good evening, everybody. Thank you for joining me again tonight. I'm going to share my screen. And I apologize. I would prefer to be in person and share hands-on diseases and discuss what we're seeing. But today, at least, we're going to do a slideshow. I'm going to get this started. See if this does it right. And of course, it swapped it again. All right. So now you should see just a full slide, correct? Thumbs up.
You are good to go.
Okay. Well, I appreciate y'all coming. So I'm just going to kind of review what we're seeing out in field crop diseases, talk about a little bit about our resources, and then I can, again, maybe hopefully leave some time at the end if you have any questions. I know I've been fielding a lot of questions about some diseases in corn in particular, but I just thought I'd review what I'm seeing, and feel free to put those questions up because I would rather have a conversation if you have anything going on this season on what, management tactics we may need to implement. Just as a reminder, and I start here in case we get short on time, I try to keep updated on things that are going on Twitter. We do have an extension field crop pathology website. On this website, if you go to it, it will have the 2 live maps that I talk about for tar spot and southern corn rust. So that's just a quick resource to go to. And then if you're interested in all our field work, the 2019 field crop pathology research trials are available. It's about 70 pages. When we get done with 2020, that's where we'll be putting up the 2020 version. So we'll be continuing to add to these each year. And then there's also the Purdue Extension publications. We're going to try to work on updating some of these, but there's a new tar spot one. And then Crop Protection Network is another resource that is available if you're looking for any of the, more information on any particular disease. Okay, so I first want to just remind you about the disease triangle. As plant pathologists, we talk about this all the time, but I just want to reiterate the 3 things that need to occur in a field before we see a disease occur. So first, we need to have a susceptible host, whether it's corn or soybeans, wheat. Is that disease, is that host susceptible to whatever disease we're looking at? So many of our corn pathogens do not go to soybeans. So the idea is we rotate between the 2 to try to minimize some of that, but we talk about soybean rust, it's a different pathogen as versus corn southern rust or corn common rust. So different pathogens, different hosts. Now, some of our pathogens may go to multiple hosts, like white mold in soybeans, goes to many crops, over 500 species, but generally does not go to any grasses. So again, it's important to understand which diseases go to which crop. And then understanding your pathogen. So many of the pathogens we talk about here in Indiana, gray leaf spot, northern corn leaf blight, now tar spot, they all overwinter in that debris. So that inoculum year to year, that's where they're staying year to year. And then they become a problem in that season, again, depending on the environment, versus something like southern rust, which does not overwinter here in Indiana. So every year we watch it move up from the south and try to track it to see, is it going to move in early enough that we need to implement a tool to try to manage it. And finally, has the environment been favorable for that disease? So most of our diseases, each specific pathogen has its own set of temperature, moisture, and leaf wetness requirements. Some may only need 4 to 6 hours of leaf wetness like southern rust versus tar spot, which needs about what we think is 12 hours of leaf wetness for that infection to occur. So again, water temperature may play a role in what diseases will be a problem or develop within that crop canopy during the season. So again, if we're hot and dry, generally everything seems to be quiet. It's been very quiet in our soybeans, whereas we do see some issues with some of the foliar pathogens in corn this season. Again, if it goes favorable, the disease may blow up in that crop canopy. When we talk about the tools we have available for field crops, generally first and foremost, if we can find genetic resistance and implement that, then we may need not to add an additional input such as a fungicide. So, if you can find out the hybrid rating or your variety rating for resistance to that pathogen, such as Frogeye leaf spot or gray leaf spot in corn, again, that'll help minimize the effect of that disease in the crop canopy. And then you may not need that extra fungicide if you have good resistance in the background. So that aspect is acting on the host of that triangle. We talk about crop rotation and sanitation. Again, we switch the crop that's susceptible, then that disease won't have a host there to infect. We can then help slowly break down some of that inoculum that's surviving year to year and reduce that risk that way. Other things we talk about is maybe burying the inoculum in the field if fall tillage is an option. You can bury some of that residue to let it break down faster and try to minimize the amount of inoculum that may be available in future seasons. If that's not an option, then you need to, again, look at the other tools in the toolbox to try to identify which tactics we want to implement. And then as some of our soil-borne pathogens, it's important also to make sure we're not moving them to a field that may not have had a history of that. And finally, we're trying to make a decision, is a fungicide going to be worth it? In timing in corn, generally a VTR1 has been our best timing for gray leaf spot, northern corn leaf blight, and then soybeans R3 when we're looking at frogeye. But it's important to get out there and scout. So scout in those late vegetative stages, see if the diseases are really active in that lower canopy. Are the predicted weather conditions going to go hot and dry, or are they going to have a lot of moisture that we might see these foliar diseases build up? And the idea is we want to then lay that fungicide out to protect that photosynthetic leaf area and the early leaf and above in the corn and the upper canopy in our soybeans. So I kind of have shared this many times, understanding fungicide timing. So the idea is, if we find a little disease in that lower canopy, it looks very conducive, that we may want to put a fungicide out at VTR1 or R3 in soybeans. When we put that fungicide out, it's going to have a residual protection about 2 to 3 weeks, depending on your product. And the idea is we're laying it there where it's protecting the yield most from that disease, where we're going to minimize the disease building up, and we're going to minimize that disease impact on yield. Maybe in another field, the fungicides don't go out for a couple weeks later, or maybe we go at an R2 application in corn. Then we're going to shift that protection. It's going to go a little bit longer into the season, and maybe you might see better control in that other field because the fungicide was there when the disease becomes more active as compared to the first location. So again, the idea is, especially when we start talking about tar spot, is we want to really identify when that disease is active and put that fungicide out when we know it's going to impact yield. And then finally, as we get to R5, R6 soybeans, we really don't, if the disease is there, it's not really going to build up enough to cause any yield impacts. So then we would need a fungicide at that point in time in the field. So our idea when we're trying to make a decision on spraying fungicides is we want to lay the fungicide down when we know the disease is could impact and build up enough to impact yield. So work has been done on gray leaf spot looking at this back in the late 90s, where they looked at how much of that ear leaf by R5 was infected by gray leaf spot. So if we're able to keep that ear leaf relatively clean, 5% are left disease, then we can see a very little yield loss occur. But as we continue to lose that ear leaf to diseases, if we lose a quarter of that leaf to disease, then we might see up to 10% of yield loss occur. And that's where maybe a fungicide put out there to protect that ear leaf would have given you that return on that investment. And then again, if the disease continues to build up, some of the issues we see with tar spot, when we lose 25 to 30% of that ear leaf, then we can start seeing almost 20% yield losses that have occurred in northern Indiana. And then the final thing is to just think about that cost. So the corn price, 3 to 4 bushels, our cost of fungicide, 15 to 35, it may shift a little bit. But if we're at $3 corn, you need to be protecting 5 bushels in order to get that return on that $15 fungicide application. If we're up at the higher end, then you may need to be looking at protecting 11 to 12 bushels in order to get the return on that fungicide. So again, it's a game of playing what's the risk of the yield, how much disease is going to develop, what's the risk of loss, and how much is that fungicide going to be able to protect and get us the return on putting that additional input out.
Hey, Darcy, we do question come in so far.
Sure. Yep.
Marty asks, can the 2020 tar spot infection come from the residue from 2018 corn crop with tar spot that was conventional soybeans in 2019?
I believe it is, and I don't know why it's surviving. So, and we can get into that. So we have lots of questions on this survival. We do know we looked at residue in 2019 and we collected it from those tar spot fields, and we know we can pull those, we can pull the spots out, we can get the viable ascospores to germinate. And I don't know if I show that, but we did show that, yes, in the Midwest, it's surviving in the residue. Now, back in 2018, we didn't know where the disease was coming from. I've been in many fields this year that tar spot is a problem, and they were soybeans last year, full tillage. So we don't have all the right tools yet developed on doing primers and stuff to test soil, but it's in our to-do list once we get a good primer set that we can really start evaluating, are these stroma, are they structures like a sclerotia? Can they survive without very little residue? And if they do, we have a bunch of inoculum ready to go, but who knows how long the survival rate is. So yes, I feel like it's survived. From what I've seen, it's survived from 2018 to this year, even if we had corn and soybeans in the middle. So we may need to go to a longer rotation, but it's blowing around so much that I just think it's here in those areas. We just got to monitor for it. That's my short but long answer. But we can talk more about tar spot as I get into it. I did want to share. So they took a bunch of fungicide efficacy trials from 12 states in the United States and combined it together and looked at a meta-analysis of putting fungicide out. And this initial group looked at the classes of the QOIs and the DMIs, and then application timings of either V6 plus VT, V6 alone, and VT. And so they ran these trials all together, and they tried to, even no matter what the disease background was, what was the yield increase. And so this table shows you that just a QOI fungicide, the V6 plus VT, had about 3.8% yield increase. The V6 alone was 0.4. The VT was 1.8. So again, that later VT timing is the timing that you're getting the return on that yield protection. With the combination, the DMI plus the QOI, the two modes of action, there was a little bit more in the V6 plus VT, a little bit with the V6, and then 3.6% yield increase over all those trials they pulled together. So the idea is, even no matter if the disease is low, will we still see what's the percent of return when we put a fungicide out if we're just going to make the decision to apply fungicide everywhere. And so then this is kind of breaking it apart, looking at these piano diagrams. So again, this is the combination, the DMIs plus the strobilurins, and looking at the applications. So the top one is V6, the middle is VT, and the bottom is V6 plus VT. And the idea is, how many times do we have a positive response, which was significantly different from 0. And so 70% of the time, the V6 application did have a positive yield response with a mean about 2.97 bushels per acre. So that doesn't quite pay for it, but and I'll show you those results. They'll plot it differently. Then looking at the VT, 73%, so it's a little bit better, with a mean yield of 7.2. So again, that we do see an increase in that yield, that VT application. And then the combination, so the 2-hit was only 8.7 bushels. Again, just a little bit boost, so it may not pay for that early application. It kind of showing this VT is where you need to stay, but you know, if you decide to go with a V6, you still may have a chance of 70% chance of getting 3 bushels per acre based on these data. And so then we pulled all that together and said, okay, what's the probability of breaking even looking at this? And this is just looking at the VT application timing. And then you have 4 bars here. So the one is the $2 bar, the low yellow orange, the brown is $3, gray $4, and the green is $5 a bushel. So the idea is, if we go into that middle group, the $3 to $4 corn, our fungicide applications generally $20 to $25 an acre. There's a 42 to 62% chance of recovering costs, no matter what the background of the disease was. So this just kind of gives you an idea of the chances, if you just decide you want to spray everything, how much you'll get a yield boost, and it'll cover that cost of putting out that application. And so then they further broke it down for the 2-hit application. So this is the V6 plus VT. Of course, we increased our costs of our fungicide program ranging from $35 to $45, and that made this chance of recovering costs a little lower. So it was 15 to 45% chance when you went with this 2-hit program of getting the cost back on yield when you apply a fungicide at the V6 plus VT. So just some data we're trying to tabulate together to try to get an idea of how well these applications are working in protecting yield. And so in 2019, we started to look at a multi-state trial, looking on some of these new fungicides. We wanted to compare the products with 3 modes of action compared to the 2 modes of action, and then looking at the VTR1 timing versus a later timing of R3. And I'm just going to present, so this is all the products we kind of looked at that are out there on the market, and then we went with a group at the VTR1, and then we repeated the group again at R3 to try to compare that. And so I'm just going to show one table of this, but we'll be pulling more data this year. So when we look at, what is this? This is across both fungicides. So all the fungicides put together. 67% had a positive yield response. So these multiple modes of action have a little higher yield response as compared to the non-treated controls. So again, there are lots of options out there. You just got to understand what they're going after and the best timing for them. I don't know if I included anything else. And then what did I break it down? So that's all of them. So this is just looking at the 2 modes of action, the QOI plus the DMI. And so again, at all application timings, again, 69% positive yield response with 3.4 bushels over the non-treated. So those were the significantly different ones. And then finally, the 3-way, breaking it apart, was 66.2% positive yield response, which was about 4.8 bushels per acre. And I don't know if I have, let's see if I have, is there one more? And no. I would say in my plots where I had them out, the only difference I saw between the VTR1 and the R3 application was where we had a little bit more control in southern Indiana with some of those products that actually went out later because the diseases moved in a little later. But again, it's dependent, you know, we're looking at both, is there a yield response and what is the disease response to these products? So again, if you're interested in fungicide efficacy tables, we put these together every year. There's one for corn, soybean, both soybean seedling, seed treatments and foliar diseases. And then we have this efficacy for control of corn. And then they did just release wheat as well. But you can use these tables, you look across them, you have the different diseases we generally rate where we can get a good rating on them. And then the group comes together on whether we want to get an E or a VG or a good, very good based on our field plot data. So you can see here just an example, and I don't know if I zoomed in or not. I do. Okay, so this is just an example. See here, you got northern corn leaf blight, southern rust, and tar spot. So tar spot was added this year. We had 1 year of data, so we were iffy on putting it in, but we decided we'd put it in just to, and kind of went with a good to very good on all those products that had a label. I know there's some now that are even have a label that are labeled, not labeled from last year, but in general, most of the products that we saw after 1 year of data did show good to very good tar spot control. But you know, if you have southern rust, tar spot, northern corn leaf blight moving in, you can cross-reference the various products and their modes of action to see which ones may give you the best output and yield and disease control. So again, here's one, the Quilt Excel has a very good for northern corn leaf blight, southern rust, and tar spot as an example. And then Flutrifol, you know, isn't rated for tar spot, but you can have, you know, it has a very good to very good rating for both the other diseases. So again, just a tool to utilize to try to identify products you may want to use in your fields. So just a reminder, diseases, just to understand what diseases are out there, and I try to keep you posted on what we're seeing regionally. We have plots across all the packs. Keep scouting your fields regularly and decide whether fungicides are needed, and then just track disease history for fields. That'll help you decide if you want to pick, you know, a crop, a variety that has a little higher resistance, maybe if gray leaf spot has gotten out of control in one field or another. And I just want to, you know, our program tries to keep you aware of this key issues, and we'll try to keep you up to date on current trends and disease development across Indiana, and then I communicate across the Midwest and the United States. So switching gears, I'm going to just jump in a little bit and remind you that soybeans have a various assortment of diseases. You know, we have everything from the root diseases, Phytophthora, Fusarium. We had a little bit, it was a little wet earlier on in the spring and late, you know, some delayed planting. Oops, I don't know why it went moved. So I know we've received some Phytophthora samples in, and I think we're still seeing some infections of Phytophthora across the state. We do watch for sudden death syndrome, charcoal rot, white mold and stem canker, and then Frogeye, Cercospora blight, brown spot, and then if we get seed issues at the end of the season. So Phytophthora, again, we've seen this a little bit this year, where you have those wet areas in the field. We want to scout plants as they emerge. They may cause a seedling rot, but they also may cause this brown canker to form on the stem. Generally, you won't see the flashing like in a Phytophthora infection. You won't see the flashing like you would do for SDS and brown stem rot in those upper leaves. But if you get down and cut open that stem, you know, it'd have this brown canker. And if you, again, if you don't know which disease it is, please send it into the clinic and we can help identify what pathogens are there. Some of the samples we've received this season may have 1, 2, 3, 4 pathogens infecting it. So it's multiple things that may have gotten in during the season. With Phytophthora rot, we do have seed treatments that are available to help manage this disease. SDS, I would say, is starting to flare this week. I was driving around in some of our bean areas at Acre. I could see it. They weren't quite in the bean research plots I have set up for SDS and my plots, but I could see other fields where we're starting to show. So fingers crossed for our research side of things, we'll start seeing a few flaring leaves. But again, you have this classic leaf symptom. The thing I'm asking is please cut open that stem. I've gotten a number of samples in and it wasn't SDS, it was brown stem rot. So it's important to take that sample, cut open that stem and see what pathogen's there. If it is SDS, the vascular tissue will be discolored versus the center pith. And I think I have a picture of that coming up. Again, we have some seed treatments that are available. We're evaluating some of the newer products online as well. So hopefully we'll have more information this winter on some of those products coming along. As a reminder, if you have soybean cyst nematode in your field, it can make SDS symptoms worse in those areas. So they open those roots for the fusarium to get in. Again, if you can see, there's some female soybean cyst nematodes feeding here on the root as compared to the soybean nodule. Again, we know SCN is across the whole state. I have another example here. So you need to dig the roots up and maybe look for those females that are feeding on the roots. The good news is we have a new nematologist. He started this week at Purdue. He is looking for soil samples. So I hope to get a note out, if not this week, next week, that he is offering free SCN counts for Indiana. So if we get samples sent in, we'll look at the counts of the females, and then we're also going to look at that resistance, and are we starting to lose resistance to a lot of our varieties out there. So again, just keep your ear to the ground, and we'll try to let you know. If you don't hear it, just email me. We'll be offering to collect samples this fall and early next spring for him to start building his collection back up, to start doing more soybean cyst research in the department. The other disease we've been keeping an eye on is Frogeye leaf spot. I would say it's relatively low. I did not find, maybe I found 2 lesions today and walking across over 100 plots in our research out at Acre. It just depends on that field history. If you have a susceptible variety out there, I've seen fields with Frogeye in it. Again, this one survives year to year in the residue. And just it's important to understand if it's in your field, resistant varieties work really well. And then if you have a susceptible variety, it's important to scout early at the R1, R2 to start finding it, and then make that decision to put a fungicide out at R3 or R4. But I'd say right now, Frogeye is relatively quiet. My plots in central Indiana and southern Indiana were really clean. So unless you have a field that's got a really bad history and you planted a susceptible variety, I wouldn't worry about Frogeye for the season. That being said, if we go wet for the rest of the season, we could end up like we did in 2019, where we did get lots of infections. So this is Frogeye leaf spot on the pods and stems in soybeans, where we're really wet at the end of 2018, and it can cause the seed damage here as shown here, which is different from the Cercospora leaf blight that causes the purple seed stain. We are, as for management of Frogeye resistant varieties, we scout at R1, R2, and then try to make a decision to put those fungicides out at R3. If you have a high incidence of disease in a field, rotation or residue management will be important. The other big question I get on Frogeye is resistance to the strobilurine fungicides. So Tennessee first documented the resistance, and in 2017, they released this paper that shows that 14 states and 240 counties did have Frogeye, Cercospora sojina, the Frogeye pathogen, was resistant to the strobilurine fungicides. With this survey, there were 4 counties in Indiana, so Clark, Delaware, Fountain, and Pulaski. In 2019, they added Georgia and South Dakota to the list. They're up to 251 counties, and that doesn't include what we were just tracking from 2019 in Indiana. So I have a student working on trying to map Frogeye resistance across the state. So she was able to get into 12 counties last year. She collected about 153 isolates and finally got back in the lab this last month and a half and tested those isolates to confirm them. We're still looking for more isolates. We're looking to try to fill this map in a little bit better, just to where we're finding, to get Frogeye, just a good distribution across the state. But again, from her results, pretty much 71% of those isolates did have the QI resistant background. So I generally say most of the populations in Indiana do have that resistance. So we really need to look at a mixed mode of action. We're trying to manage this disease and we're putting out a fungicide. But it was interesting to find that we had one county here, Lawrence, from all the samples, there was no QI resistance in any of the samples. So there may still be some variability in some of our fields where one field may have still have a susceptible pathogen population. We're going to continue to sample in Lawrence to see how widespread that is if we can find QIs, but we are still collecting samples. So if you get a hot spot and you want us to send a sample, we'll be collecting those this season as well. So again, for these fungicide resistant populations, rotation will work with a non-host to try to minimize that inoculum in the soil. And then we need to make sure we're adding something other than the group 11, the strobilurin and fungicides. So the DMIs, the triazoles, the group 3s are rated pretty good for Frogeye, leaf spot, and the NBCs, the thiophthanates. So our recommendation even now, even if you don't know, is put a mixed mode of action out to try to minimize that selection pressure. So that was it for soybeans. What's my time? We'll switch to corn real quick. So again, in corn, there's a bunch of foliar diseases we're monitoring: gray leaf spot, northern corn leaf blight. We monitor the rust, the common and southern. Gauss's wilt is around, but I still have yet to get a sample in since I started here at Purdue in 2018. I would say I see a lot of physoderma. So I have a plot up at acre that I'm going to go back in and rate for physoderma because it seems like there's, at least I have some fungicide differences in my mind, but I can see it in 20% of my plots have physoderma there. We're also, northern corn leaf spot is another disease we're starting to see a lot more up in the northern part of the state. So we need to keep an eye out on that. I just had a phone call this afternoon with a field. It was a sweet corn field, but they were hit really hard with northern corn leaf spot. So again, just something to keep an eye out. And finally, tar spot as well. And then watching our stalk rots and ear rots. I do think I've seen a few Fusarium and Gibberella ear rots already starting in some of our southern plots. So we need to keep an eye out for those. Watch for the stalk rots on stalk integrity when you get ready to harvest in the next month or so. Okay, so first start with southern rust. This is a disease that does not overwinter in the United States. It blows in from the south every year. The thing about southern rust is if it gets in early, we may need to put some foliar fungicides out to control it. I believe in 2017 or 2012, there were some epidemics of southern rust in Indiana that caused some significant yield losses in the southern part of the state. So we have been monitoring this. The thing about southern rust, for me to turn a county ready, yellow, and I'll show the map shortly, is I need to see it under the microscope to confirm whether I have southern rust or common rust. Generally, we look at this oval versus circular spores and the way the spores are designed. And so sometimes I get out there and I really think it's common, there's no southern rust, and every once in a while we'll pick up one. So it's important, if you're not sure and you think you have southern rust, to send us a sample. And I almost think my pictures look switched. Now let's show that. So anyhow, let me go back here. An example, southern rust, they're very tight clustered pustules. They're rupturing open. I think they're a little yellow orange in color as compared to your common rust. Common rust is going to be sporulating on both the top and bottom of the leaf, whereas southern rust, we really only see the sporulation on the top leaf. I look at my pictures, they look switched. So this is the map that we've been tracking for southern rust in the United States. Georgia and Mississippi got hit early, so they were warning about it, and they were seeing a lot of it down south. My colleague in Mississippi, as he was rating his plots, he took a picture of himself and he was covered in orange, like from head to toe, like he just got painted orange. So we know the inoculum was heavy. We had that hurricane weather systems move up, so we were watching it. I can't remember when we first found it, but these are the counties we found in Indiana. So we haven't found it all the way up into northern Indiana. And we've been in some fields where it's been built up in pockets pretty heavily. So it's just important to understand it is here. I think most of our corn is reaching that point that we really don't need to do anything about it. The research that's been done on southern rust really has the spray up to about R3. At R4, they really don't think it's going to be much of, to get that return on investment to go out at R4, but it just depends on how severe the disease is building up in a field. So many of our fields, when we first saw it, we're finding it now, It's beyond R4, we're approaching R5, so we're really not recommending a fungicide spray, but just keep an eye out for it. So we did do a foliar disease control in Indiana. This is part of that trial I mentioned earlier, looking at these different timings. So as you look at all the products for southern rust here in Indiana, everything worked, and there was no really difference whether you went at BTR1 or R3. We only got about 12% in the disease in the non-treateds. So that means that if you look at the yields, we really didn't see any differences in our fungicide treatments on yield. So there was really no significant yield boost for putting the fungicide out because the disease never built up beyond that 11, 12%. If you look at some of these products, gray leaf spot and northern corn leaf blight, I don't know if I highlighted them or not. Oh, here it is. So I kind of highlighted the lowest one. So you can see some of the products, northern corn leaf blight moved in a little bit later. So that later application held out a little bit better for some of those northern corn leaf blight, and then all of them worked really well for gray leaf spot. So then again, you know, you can just pick one product and it may cover everything that we're trying to manage in corn. It's just getting it out the right timing. And so finally, we'll switch to tar spot. Some things I wanted to consider first, did you have a history of tar spot on your farm? If you've seen it, you've been affected by it, those are the fields that I'm most worried about for this season having a problem. That being said, we did see it spread. So this is last year's map. The dark red counties are, the dark red is where we found it previous years in 2019, or the bright red where we added in 2019. I do hope to get down in southeast Indiana to see if I can find it. When I get down to that central to south part of Indiana, it's still like a needle in a haystack to find, but it is important to understand if the disease is present and the weather conditions become conducive, it may become an issue. And I would say there's a little pocket by Knox County. It was Sullivan County where I saw a sample that I was a little surprised at the amount of tar spot that was on it. So it is important to understand it's pretty much, I suspect it's in all the counties here in Indiana. We've found it since 2015. So it was here in 2015 through 2017. And then 2018 is when we got hit, where we had those right environmental conditions that just caused it to blow up in the northern part of the state. And then again, where we continued to scout for it the rest of 2019. In the 2018 epidemic, we estimate about 30 bushels per acre were lost. When you get out into one of those fields, if you haven't been in it, every corn plant is infected. Usually you have 50% severity on that ear leaf. It's just burned right up. And this this blight that occurs can happen within a couple weeks. You can leave the corn, it'll be green one week, and you go in it next week and it's just blighted. How fast this disease takes off is kind of astounding. So there's 9 states that now have tar spot. It moved into Minnesota and Missouri last year. We estimate we lost about 120 million losses, or $120 million to tar spot in Indiana, about 3% across that area. So we're continuing to scout for it. It's produced by this Phylocoramatus, is the disease that causes this, there's the pathogen that causes this disease. It produces these little stroma. There can be small pinhead size, as you can see, some small ones, and they may grow larger depending on how long they've been developing. They release ascospores from the residue. Those ascospores can be ejected up to the canopy, and that's why we can have every plant in a field infected. And there's a lot to be learned about this pathogen. There's been very little work done, and no work done here in the United States until this last couple of years. So the life cycle of the pathogen, we did prove that it is overwintering here in the residue. During conducive conditions, the ascospores are released and move up into the foliage. I suspect, we haven't nailed this down, there's a plant age, so we want a leaf of a certain age before we really see infection, late vegetative stages, and generally about 14 to 21 days after that ascospores landed, we start seeing that stroma, and then those cycles can continue to repeat through the season. We get this rapid infected tissue, there'll be a chlorosis, necrosis, blighting, and sometimes what we call a fisheye spot too as well. But again, that residue is then left to the soil. So I think it was building up for a few years, and then we had the right conditions, the storm, to cause the problems in 2018. And then that just blew up our inoculum load across the Midwest from now on, I think. So this is the needle in the haystack when we begin scouting for tar spot. Finding one stroma in a field, that's hard to find. Generally, we're finding on the 4th leaf or lower leaves when we're looking for it. But then, so this is an example of, this is a leaf I found in 2019. You know, the stroma, if you look at it, it's embedded and growing in that tissue and you can't scratch it away. It's not quite a black, it's got a brown-black edge to it. And it's got this raised, if you look closely, it's a raised structure in the middle. But this is what happened a week later as I sent my student back. And that's how fast we can go from hardly being able to find one to going out and finding hundreds easily. And so this is the unique thing about this disease. It's got this rapid disease development within the crop canopy once it gets going. So this is just kind of a range of the symptoms. And so we may or may not see this fisheye lesion develop. I've seen a few this season. It was initially thought we needed 2 pathogens to cause tar spot to be a bigger problem, but we've learned we really only need the Phylochora. We're still not sure if this lesion is just secondary pathogens moving in or a reaction of the host. But again, all we need is these stroma, the Phylochora, to cause significant blighting. There are a couple disease look-alike disorders out there, and so the biggest one early on is insect frass. And I still, when I was trying to find an acre and I didn't find any today, there was lots of little insect spots, and so those rub right off or scratch right off. So I try to tell those that call me, did you scratch at it? It won't come off. Sometimes our Physoderma brown spot, as it's just beginning, may mimic it as well. It also may mimic southern corn rust too. So again, just look closely at Physoderma. Physoderma kind of produces bands as it's growing out on that leaf tissue. And then as our rusts age, they'll turn black, so they may mimic tar spot. And then the saprophytic fungi that move in at the end of the season, this is where I think we were missing it earlier on, is it didn't move in till late. It kind of mimics this. We didn't realize there was anything going on, whereas this pathogen was slowly building up for the last few years. So again, this is kind of the symptoms we saw, well, last year. We haven't quite seen the blighting yet here in Indiana this year. But again, this is an example of field. The farmer left the field, it was green, and he came back from a vacation from a week, and it was all blighted. And so this is the fast blighting that occurs. There's a lot of stroma being produced on that leaf tissue. So he gets to that certain point, and the whole leaf just shuts down. Again, as you can see, lots of different stromata. So these little black structures, they're the fungal structures. They're the overwintering structures. Within each one of those, it's producing all sorts of ascospores to be released. So you can see there's this rapid buildup that can occur. We can even see it on the husks as well. And so we began scouting in Indiana. I wanted to not only find it, but determine how severe it was. So I did a severity across the state when we did our scouting on 2019. Just to get an index of where the risk is. And so this kind of map kind of shows where our greatest risk is. That northern part of the state is where we had significant infection. Ear leaf and above was greater than 5%, 15%. We were still seeing the blighting and the yield losses there in that Lake Porter, LaPorte, St. Joe, Elkhart counties are where we continue to see yield losses in 2019. When we get down to central and southern Indiana, it's again the needle in the haystack, kind of hard to find, but again, because of the environmental conditions that may push this disease, it's important just to know the pathogen is there, just to keep an eye out for it. So again, and then the next thing we're trying to consider is fungicide application. So again, we monitored, and we have up at Penny, Purdue, we actually got a good site to monitor for tar spot. And so we tracked it in 2019, and the ear leaf -2 and the ear leaf +2. So we were watching its movement up in that crop canopy. And as you can see, it's laying low, it's at 1%, we can barely find it. And then all of a sudden it begins to spike, and then we have this almost, what do I want to say, rapid explosion in the crop canopy. And I would say my students were out there today, and we went from what I would call 0.01% incidence on our ears, so 1 or 2 spots, to they got hundreds already. So we're starting to ramp up. Our corn is still at R2, so we're starting to see the curve take off again as it begins to mature. We intentionally went in later so we can follow this disease and get a good disease curve develop. But we are starting to see this. I'm going to be up there again tomorrow to look, but it's starting to blow up, and we can find it almost on every leaf in that crop canopy. So this is the thing that happens, is that once it gets going, it's got this rapid development within the crop canopy. So we looked at this and tracked this in all our plots. And so this is a 2-week difference between our plots. So in September 21, and when we see September 21, we were still at like 5% of the stromata. We could find 5% stroma on those leaves. Corn's still green. We went back to about 2 weeks later, and it's just ripped right through and blighted That's that rapid progression that occurs in our non-treated. So this is kind of what has scared a lot of the farmers in northern Indiana that have experienced that. And so that's what we're trying to look at, is how do we manage this and how do we best time our fungicides. So we had a bunch of trials out looking at efficacy, timing, hybrid by fungicides. So you can see there are still some plots that remained that still stayed green at Penny at the end of the season. We looked at all the different products. We started at the VTR1 state application. And so this is looking at just applying at our standard VTR1 timing. Fungicide went out, 2 to 3 week window of activity. And so here's our non-treated disease curve and then our fungicides. So you can see the good news is all our fungicides shifted the disease curve down. But then at that point, just before the 23rd of September, just before R5, we start seeing the disease take off. The fungicides have run out of their activity, and the disease is and tar spot begins to build up again. We didn't get to see it blow all the way through, but some of us worry if the disease starts earlier, will our fungicides need to be shifted earlier, or do we need to hold them off to later? So those are some of the questions we're looking at this season. We started spraying at V8, and we're going all the way to R5 this year, just to try to understand, is there still yield loss? Are we still using yield between that R4, R6 period? Would a fungicide been beneficial at that point in time is one of our questions. So again, the idea is we're protecting the ear leaf tissue and above. This is looking at necrosis, how rapid the necrosis occurred. So again, we had almost 60% of that plant was necrotic. Our fungicides help them stay green longer, or the opposite, we were 30% green on our non-treated check, and the fungicides helped it continue to stay green to finish that crop to get it to black layer. When we looked at the yields in our first trial, we did have some variability in our yields. Disease only got up to about 23% in that non-treated check in the green bar. The change in yield, which didn't separate significantly, was 3.5 to 21 bushels per acre. So there is that 20 bushel per acre potential. I had a bunch of other different trials, and I'm just going to show you real quick. Again, they all acted the same. Those fungicides shifted the disease curve. When we look at when this disease gets over that 35%, here it's at 40%, then we start seeing those yield benefits come out where it rapidly causes yield loss. And in those trials, it was about 17 to 20 bushels per acre when we had a significant amount of disease. And when I looked across all my trials, 7 of the 9 trials had 35 to 40% of that ear leaf with tar spot disease. And those were all about 17 to 20 bushels yield boost. The 2 trials that didn't have the significant yield difference were those that were relatively low. So again, when this disease takes off, it does have that risk, at least 20 bushels we can protect, at least with fungicides. The question is there more yet to protect beyond that? And we don't know. So we did look at timing. Again, we started early, so looking at the early vegetative timing, same diagram. Those early timings missed when the disease moved in. They didn't really shift the disease curve lower. It's that R2, the VTR2 timings were what shifted the tar spot down and reduced the yield impacts. And again, we saw the same thing, and I don't know if I highlight it. So the VT and R2 application timings, that's when we saw significant yield protection, and it was almost 20 bushels per the acre, those timings, just using Tripper Pro here in this trial. So again, we know that for tar spot, we really need to have those later timings. It's moving in generally later, so that VT or beyond may be our best timing for this disease. We're continuing to track it. We're doing modeling because we know weather is greatly influencing tar spots. So we have an app. Oops, I lose the app. So we have an app we call Tar Spotter that we're trying to validate. Last year it did not work in Indiana. They were missing all our rainfall. And so now with the new model, I think, well, fingers crossed they'll get it, but our model hasn't kicked in again at Pinia. So I'm not sure. We may need to shift a little bit, but we're playing with a model that would give us an idea of when we've had the right moisture conditions and temperature conditions to really cause the disease to take off, to better time our action threshold for these fungicides. But again, looking across all the states, that VT to R2 timing was the best timing based on last year's data. What else do I have here? And the other thing I just want to note is when we have significant tar spot, it's causing those stalks to be starved, and we did see a lot of lodging. So and these plots were clean at Penny, so there was no other stalk rots present. It was just the starvation from the tar spot blotting for that corn to try to finish. And so we're going to continue to track it. This is my current map as of 2020, and I think I got to add Knox County today. I got an email from the clinic. But again, where we're finding the most activities up in northern Indiana. We know it's in 68 of the counties already, but we continue to track it now as we approach the end of the season to see how widespread it continues to be. And the one thing we've learned even the last couple of years is this environment is driving this disease. So even though a fungicide may be applied, or you may have found a hybrid that may have a little more resistance, if the environment is right, it may push through that. So this is just an example of up in Michigan where they had to go in with multiple irrigation timings in a week. So instead of putting down 1 inch at one time, they were putting ½ an inch twice because of a pump issue. And because they were keeping that leaf wet longer, there was more time for the disease to really build up underneath that irrigation line. So again, we're looking at irrigation, particularly up in northern Indiana, and how these light irrigation events may even drive the disease more. And then trying to figure out best timings for when you want to time irrigation, to get the leaves to dry down fast enough to try to minimize disease risk within those areas. So again, for tar spot, if you can, try to avoid susceptible hybrids. Hopefully we'll get more hybrid data out in the next couple of years. If you're looking at fungicides, we're recommending a mixed mode of action, but again, timing is very important. So I had many of our growers that were watching tar spot closely, hold off on not trying to go too early, maybe spray it R1, R2 to make sure that fungicide was out there if they were in a field where it was starting to kick up. And we're going to look at managing irrigation, and we really don't know how well rotation and residue will work for managing this disease yet. So that's just a quick review. I kind of said that all already, but again, we've seen it every year since 2015. We've got the inoculum here, especially in the northern Indiana. It's going to be an annual problem for some of our farms, just depending on the weather or water events they experience. So I guess I'll end here. I'll leave up my contact information, and I can open up to questions because I think there's some out there. See if I can see where they are. Or can you guys read me questions?
As of right now, we don't have any questions
no
in the chat box.
Okay.
But if anybody does have any questions, feel free to type them in the chat box here, and we'll get them answered.
I got a few minutes left where I can answer some things. But I could say the biggest question I've had is whether to put a fungicide out or not in corn this season. And it just depends on how the activity of what you had going on your field. I would say gray leaf spot was there. Where we have continuous corn, it's creeping up. I maybe had 1% on ear leaf, so it's still relatively low. And then just monitoring, there are hot pockets of southern corn rust as well. Any questions? And luckily, beans look beautiful, I think, for most of the part, other than some hot pocket. I haven't heard much white mold either in the state. Trying to think what else.
All right.
I guess no questions. I can hand it over to you.
All right. Thank you, Darcy.
Right,
we'll go ahead and put the screen up for your credits. Just 1 second while I navigate that here.
There's someone in the waiting room. Did he get out accidentally? Or you let him in? Never mind.
All right. Okay, you should be seeing the screen here. You can, if you have the CEU app, you can take a picture or scan the code in. If you don't have the app, you can put your license number into the chat box, and we will take care of getting your credits.